Greetings, my name is Rachel, and I would like to represent our group SwiftBit to present on problem solving tool, which is real-time operating system. Our group SwiftBit consists of me, Rachel, my team members Kinkiet, Diana, as well as Ani. Now, I would like to present on the introduction for our problem solving. For our problem solving, we actually have the opportunity to work on real-time operating system, where real-time operating systems are actually essential in embedded system to actually manage multiple tasks with deterministic timing and also to ensure more efficient in terms of resource handling. In our practical session, we're actually able to explore more on the concurrent programming by using the micro C OS tool, which is a reliable real-time operating system that is widely used in the safety critical applications. Next, the same problem scenario will also be solved using FreeRTOS, which is a lightweight open source real-time operating system with more broad community and industry support. Through this activity, we actually aim to understand more on how different RTOS actually able to handle task scheduling, synchronization, as well as inter-task communication, and we're also able to compare the features and implementation between different micro COS2 and free RTOS. And last but not least is, from this lab activity, we're actually able to evaluate both real-time operating systems in solving the same concurrency problem from the lab assignments.
Good day, doctor. My name is Kenket, and now I will demo the program. So basically, the first question of the lab exercise 3 is about changing the ASCII character from A to Z to 0 to 9. So basically, in order to change the display message, so we modify the TX MSG from A to 0, and then next, in this if else statement, we also change it to the from Z to 9 and then A to 0, and this will change the ASCII character from displaying the alphabet to the number. And then next, to increase the wheel speed, the rotation speed of the wheel, so by factor of 2, we reduce the OS time delay from 10 to 5. So we modify all of the OS time delay from 10 to 5. And also the same for the task 3, we reduce the OS time delay from 20 to 10. So all of these 4, we reduce it to 10. And then now I will show how to compile the program and run the program. So we compile the program and then we run the program. So this is the output of the program. So as you can see, the message box already changed from alphabet to the number, and then the rotation speed of the wheel already doubled. And for the CPU usage, it is still the same as the original speed of the wheel. So by increasing the wheel speed, the rotation speed of the wheel does not increase the CPU usage. So that's all for me. Thank you.
Okay, now I will be presenting the demonstration for Lab 3 when using FreeRTOS. So we start with defining the libraries for the program. And then we define the tasks, the priorities, and task handles. And then this is the main function for the program, which is starting with creating the mailbox for task 1 and task 2. And next is creating the TXQ for task 4 and task 5. And so here is the code for the task being created. And this is the function for the task, which is task 1, task 2, task 3, task 4, and task 5. So now we start with building the solution. And when the solution is built completely without any failure, we will start with running the program. So when being run, this is the output for the whole for the program. So here, as you can see, is the task 3 working, task 4 sending messages, task 5 receive messages, task 1 sending, and task 2 receive. So that's all for demo lab 3 when using FreeRTOS.
Next, I am Lorena and I will be presenting about the discussion on both solutions of this problem solving. First thing first is related to the task management. So microCOS 2 use OS task create as standard with defect control, while FreeRTOS use X task create, which is more simple and easier to use. But both of the solutions actually support priority and also able to multitask. Secondly, is inter-task communication. So microCOS 2 use Mailbox for single message exchange. However, FreeRTOS use two which are more flexible and support multiple data types compared to the microCOS 2. Thirdly will be the ease of use and flexibility between FreeRTOS and also microCOS 2. So FreeRTOS offer more premium syntax, easier API, and more flexible to use compared with the microCOS 2. However, microCOS 2 also provide like more built-in task diagnostics like tag check, but it is more complex compared to the FreeRTOS. So that will be the end of our presentation. Thank you, Dr.